Before we finish deriving the theory of labor demand, I want to turn to two measures of productivity that are showing up in the production technology that we're using. The first is, if we have constant returns to scale, then we can write a production function that looks like this. It just says you take capital to some power, alpha, and then you take labor to some power 1 minus alpha. Because these exponents sum to 1, we know that we have constant returns to scale. And in US data, the number for alpha looks a lot like this. It's roughly 0.36. Alpha is also called the capital share, and therefore 1 minus alpha is the labor share. So there are two different measures of productivity that get used quite a bit. One is what I mentioned before, this Z, which is total factor productivity. And that's literally just defined, if you have this production function, as output divided by k to the alpha, n to the 1 minus alpha. But another more common measure is average labor productivity. Average labor productivity is just take total output and divide it by total number of hours worked. So that tells you how much, on average, each hour of labor produces. Now you'll notice that to compute this measure of labor productivity, you don't have to know alpha. You don't have to know what the production function looks like. So there are real advantages to the measure of productivity that is called average labor productivity. But the drawback to average labor productivity is that while it does depend on something that is exogenous and outside our model, this total factor productivity, it also depends on this capital labor ratio. And this thing is endogenous. So what that means is if you see that average labor productivity has changed, you don't know whether that's happened because of something exogenous, meaning the TFP shock, or something endogenous, something having to do with the amount of employment. So Z really is an exogenous object, at least given this production technology. But the downside to Z is you have to make some assumption about what the production function looks like. And you have to know something about what this alpha parameter is. Now, there's some important characteristics of productivity. One is that productivity does grow over time. There's a positive trend, but it fluctuates around that trend. Productivity is very strongly positively correlated with output, and large declines in productivity tend to coincide with recessions. It's also the case that these two different measures of productivity that we were just talking about are highly correlated. So the correlation between them is 0.93. So this table just summarizes how these two different measures of productivity are correlated with various things that we might care about. So the first object is, this is the growth rate of GDP, this is the growth rate of employment, and this is the growth rate of capital. And what you see is that both measures of productivity are highly correlated with output. TFP is fairly highly correlated with labor growth, but average labor productivity is basically not correlated with labor growth. And neither measure is very highly correlated with capital growth, and in fact, maybe negatively correlated, if anything. So this is a chart of one measure of total factor productivity. And what you can see right away is that the 1960s, look at the slope. It's quite a steep slope, meaning that there was quite rapid growth in total factor productivity. But then in the 70s, productivity growth really stagnated. And then it picked up. It was sort of pretty good in the 80s. And then in the 90s, it really picked up again, comparable to what was going on in the 60s. And then it just fell out of bed. And that is the recent financial crisis and recession. This is just the percentage change in total factor productivity, and it's shown relative to these recessions. So the beginning of a shaded area is a peak, and the end of a shaded area is a trough. So this is a business cycle. And what you see is that TFP tends to bottom out at the early part of a recession. Just look along here. And then it tends to rise. Now, this latest recession, it seemed to bottom out kind of late in the recession. But then after the recession is over, you tend to get these kind of big increases in total factor productivity. And of course, as we said, it's quite highly correlated with output. And one thing that should jump out at you in this graph is output, which is the blue line, is quite a bit more volatile than total factor productivity. So what this is saying is that economic decisions tend to amplify the effects of total factor productivity on output. And this is that second measure, labor productivity, but it was really the same story. Productivity grew quickly in the 60s. It was very sluggish in the 70s. The 80s, it started looking a little better, but it didn't really pick up again until the 90s. And while it didn't fall completely out of bed in this latest recession, it certainly did dip down. And again, as we said or we saw in that table earlier, average labor productivity is correlated with output, not as strongly as TFP. And as with TFP, what we see here is that output is more volatile than this productivity measure. And the two different productivity measures are quite highly correlated with each other, so they're moving together pretty closely over time.